we left off here uh, talking about nomenclature. Well, not really talking about nomenclature, but how to put ionic compounds together, right? And so if you recall from the product table, an ionic compound is when you add a metal plus a nonmetal, right? So now we're gonna learn how to name these things, okay? Just briefly, we'll go in super deep detail on how to name them later, but this is just kind of an overview right now. Uh, so this is called chemical nomenclature when you're talking about naming things, okay? And you will learn how to name ionic compounds, acids, binary molecular compounds, which are the ones that are just nonmetals and nonmetals together, and then very simple organic compounds too. I won't spend a lot of time on simple organic compounds because you'll do that in organic chemistry, right? So, but we will spend a lot of time dealing with the first three right here, okay? So it's like we said before, we said this last week already, right? For inorganic nomenclature, which is the ions, right? It's always going to be the metal first and then the nonmetal, right? So write the name of the cation. So sodium would be a cation, right? If the cation can have more than one possible charge, write the charge as a Roman numeral. So that would be like the iron has more than one charge, cobalt has more than one charge. Anything that's in the transition group right here has more than one charge. So when you see any element that's from the transition metals, it will always have a Roman numeral behind it to tell you what charge it is. But if it's a metal from like either the alkali metals or the alkali earths, right, you don't have to put a Roman numeral because sodium will always only have one extra electron to give up. Magnesium will always have two extra electrons to give up. So those charges don't change. But for the transition metals, they do change, and so you need to have um, a Roman numeral, and I'll show you what that means in a second. If it's a polyatomic cation, it will end in ium, right? And I'll show you that in a second. Um, like ammonium, right? And then if the anion is charged, it ends in ide, right? So we'll talk about that too in just 1 second here. Okay, so we also have this thing called oxyanions, right? Which are ions that have oxygen in them, right? So when these two oxyanions involve the same element, you have ite and ate. So the question then is, how do you tell the difference? Which one's ite and ate? Ate will always be the polyatomic that has an extra oxygen, right? So look at sulfate here. Sulfate has an SO4 2 minus, that's its charge. But when you have an SO3 2 minus, it's sulfite, okay? So what I like to say is that the most common version of the ion is going to end in ate, right? And so the most common version of this ion here is sulfate, right? And it ends in ate. It has 4 oxygens. If you look at nitrate, though, nitrate's the most common version here is NO3 minus. It has one charge there, right? But if you go down an oxygen, you'll lose an oxygen. What do you get? You get ite, right? Does that make sense? So the most common one will always have the 8, and then the one that has one less oxygen than the common one will be ite. Okay, and now these aren't the only two, right? There's also phosphate, which is PO4, right? 3 minus, but phosphite is what? Exactly, PO3, 3 minus. Does that make sense? So it's always going to be one less than the most common. Okay, one less than the most common. And I have a feeling that I have a picture coming up that is going to say all this, and I'm going to repeat myself. So here we go. I do have to repeat myself. Okay, so patterns in oxyanion nomenclature, right? So here's another one. Here's carbonate, right? Carbonate is the common one here, right? We have nitrate, phosphate, sulfate, and perchlorate. Those are all the common ones, right? So notice here we had sulfate. If it loses an oxygen there, what is it called? What is sulfate called if it loses an oxygen? Sulfite, right? If it's phosphate, right, which is PO4, 3 minus, if it loses one of those oxygens and becomes PO3, what is it? Phosphite, right? Same thing here. Nitrate becomes what? Nitrite when it loses an oxygen. Okay, so this is just a picture of the common polyatomics that have ite and ate. Okay. Central atoms in a second row have a bond at most 3 oxygens. Those on the third row can take up to 4. Charges increase as you go from right to left, right to left. Okay, which makes sense, right? You already knew that before anyway, because This is group 7, has a -1 charge, right? Group 6 has a -2 charge. Group 3 has a -3 charge right there, right? Uh, if this was nitrogen by itself, it would also be -3. So it still follows all the same rule as before, with just one little exception there. Okay. So to continue the patterns, right? And I said this a second ago, right? Say you had the simple chloride ion, right? And the chloride ion has no oxygen in it at all, so it's just called chloride, right? But then you add some oxygens to it, right? And then you have the one with 4 here, right? If you have 4 oxygens in this added to the chloride, it's called perchlorate, right? If you have chlorate and it has 3 oxygens, it's just the chlorate. And the way you can remember this is remember that if you remember, I finally figured out how to draw on this thing. Okay, so remember we have water, which is H2O, right? And then if water gets an extra oxygen, right? Let's say plus an oxygen, what does it become? It becomes H2O2, right? So most people don't know that water is like nomenclature name is hydrogen oxide. So what do you think this is called? Hydrogen peroxide, right? The stuff that we talked about before, where your mom would just throw it on your skin whenever you had a cut, and it would bubble up, right? It bubbles up because it kills your blood cells and it kills the germs, right? So whenever you notice that water added on an oxygen, right, it became hydrogen peroxide. Okay, so same thing here, chlorate, right? Added on an oxygen, it became perchlorate. Okay, so the common one here, right? That was weird. That was really weird. The most common ion then is the chlorate ion, right? And if you add an oxygen, you add a per to it, okay? And then the rest of it, I said before already, right? If you lose an oxygen, it becomes the chlorite, right? And then if you lose another oxygen, it becomes hypochlorite. So hypo here actually means one below, right? And so hypo, like, hypodermic, like below your skin, right? And so chlorite, which is already lost one oxygen, and then hypochlorite is losing another oxygen on top of that. So losing 2 oxygens, right? So remember, it's always perchlorate, chlorate, which is the most common, chlorite, and then hypochlorite. Okay? So, and everything I just said is in words here, just so if you need to read it again, right? If you need, it's all in words down here. So, dang it. For some reason the thing's not working. Maybe I would turn on and off. There it goes. Okay. So here's your first question for today. Which of the following is not an oxyanion? Which of the following is not an oxyanion? And I just answered this. This was just on the previous slide. So, oh, what number are we on? Oxyanions. There we go. Which of the following is not? Oh, are you serious? Which one did it show? Oh man, hold on. Let me go back. Is it something that we've already answered? That's what happens. So that's what happens. Yeah, it is one we've already answered. Dang it. That sucks. Wait, is it something that we've already answered? Or has everybody already answered? Is that why it's so fast? Because usually if you answer twice, it tells you that you can't answer a second time. Yeah, it's making you answer twice. That's okay. Go ahead and answer it. I don't want to fix it right now, so just go ahead and answer it. We'll see how everybody comes out. Huh? Yeah. If it allows you to. Allow this one. Answer this question on that. What happened was I just put in the wrong QR code. They look so the same. They look all alike to me. All right, so I don't know if this room can switch over back and forth. Can it switch back and forth? I'm still waiting here for someone here. Okay. Well, with the other answer in there too for the ionic thing, right? The answer is in fact A. So most of you got that one right. I hope that most of you answered A there. Okay, because I put the wrong QR code there, right? So the only one here that's not an oxyanion is chloride, because chloride has no oxygens on it. It's got a -1 charge. It's just Cl minus, right? Chlorate is the most common. It's got 3 oxygens. Still a Cl minus. Still a -1 charge. Perchlorate has 4 oxygens. Chlorite has 2 oxygens, right? Good stuff. So when we're talking about oxyanions, because now we have to talk about how to name acids. Okay, if an acid ends in "ide," change the ending of the acid to "ic," right, and then add the prefix hydro. So this is actually called a binary acid right here, right? And the reason why it's a binary acid is because it only has 2 elements in it. Okay, so hydrochloric acid, right? The "ic" comes from the chloride. The hydro comes from the hydrogen. Then bromic acid, hydrobromic acid, hydro from the hydrogen right there, and the ic from bromide, and the hydroiodic acid, right? So I want you to know right here now that no acids will be named hydro if it has more than 1 element. More than 2 elements in it. Okay? Same thing. It's the same thing, right? So the only reason why I say don't have not an oxygen is because you'll learn later in chemistry that there are other acids that will have oxygens, right? So that are not going to be like this. So, but at its most basic and simplest way, I would say binary acid means just 2 elements. Okay, does that make sense? And so, if it's a binary acid, it's always going to begin with hydro, and it's always going to end in ic, right? The middle part will just be the ion that's in there, right? And then when you have the oxy acids, right? Then you have the oxy acids, right? That's when you don't have hydro anymore. For example, this is chlorous acid right here, which is ClO2, right? The one that was just below ClO3, which is chlorite, right? This is chlorous acid. Notice it's just chlorous acid. It's not called hydrochlorous acid. It's called chlorous acid because it has oxygens. It has more than 2 elements. We go down a step further, losing another oxygen. That's hypochlorous acid, right? If you go forward, right? If you go forward, and it ends in 8, right? If it ends in 8, then you change that to ic. So here's chloric acid, and here's perchloric acid. So you have the ite always gets changed to us, right? 8s always get changed to ic. Notice the difference between. Be sure that you see the difference and you are aware of the difference between chloric acid right here, right, and hydrochloric acid. Okay? Do you see the difference between hydrochloric acid and chloric acid, right? Because hydrochloric acid is the binary acid, HCl, right? 2 ions, contains only 2 ions, right? Whereas chloric acid, right, contains more than 2, contains 3 different elements. Okay? Makes sense? That kind of pattern will be there with other ones too, like hydrogen sulfide makes hydrosulfuric acid, right? But then you'll have sulfate, which is sulfuric acid. Okay, we'll go through them all in a second. So just remember, 2 for binary acids, right? Two elements for binary acids always begin in hydro, always ends in ic. Okay, and then if it's a polyatomic with an oxyanion, if it ends in ite, it becomes us, and you don't have hydro. And then if it ends in 8, you change it to ic, and you still don't have hydro. Okay? Don't worry, we'll be doing a lot of practice with this in the next what's it called? Discussion. Okay? So nomenclature of binary molecular compounds. This is actually a little bit easier. Okay, this is a little bit easier. Binary molecular compounds are literally compounds are all nonmetals with other nonmetals. Okay, nonmetals with other nonmetals. And so first thing you need to learn is the prefixes. Mono means one, right? Like monocole, like one glass in your eye, like the peanut guy, or maybe it was the Monopoly man, right? Di means two, tri means three, tetra is four, and the rest of them are pretty self-explanatory. Penta, like the pentagon, hexa, hepta, seven, like heptuplets, right? And then octa, like octopi, right? And nana is 9, deca is 10, right? So it's quite simple. And the most common one, like I know we haven't talked about it, but another class talks about it a lot though, right? But like, for example, CO2, right? CO2, which is the thing you breathe out every day, every second of the day, right? Is carbon, right? Which is a nonmetal, and oxygen, which is also a nonmetal. And there's two of them there, right? So what is the name of this compound? Exactly, carbon dioxide, cardon. I must be thinking about something else. Carbon dioxide. Right? What if it is terrible handwriting? What if it's just CO? What's that called? Carbon monoxide, right? We talk about carbon monoxide a lot in forensics class. So, and this can be true of any of those, right? If there's, say, if there's any nonmetals put together, you always have the second element, right? Have the Greek prefix for how many there were. Okay. So, oh, see, this is what I do. I jumped the gun. I jumped the gun again, right? So, ending in a second element is changed to "ide," like we always do before. The second element is always changed to "ide," like we did before the ionic compounds, right? So we have carbon dioxide here. Here's a fun one, right? We have carbon here with fluorochlorines, so we call that carbon tetrachloride. Okay, carbon tetrachloride. Here's carbon monoxide here. Here's one with two of the first element. So again, we use the Greek prefixes, which means it's going to be dinitrogen pentoxide. Get it? Right? It's super. The nonmetals are super easy to deal with. Super easy. Okay. Nonmetals are super easy to deal with because it's just the Greek prefix in front of it. Okay. Here's your next question. Which of the following is not a binary acid? Which of the following is not a binary acid? This better come up with the right question. Did it come up with the right question this time? Thank God. I promise I'm trying to make this work. Which of the following is not a binary acid? What the heck? Hold on 1 second. I'm so sorry. Again, this should have asked which of the following is a binary acid. I'm so sorry. I'm going to fix that real quick, just so the next time I teach this class. That being said, most of you are getting it right anyway, even though I screwed the pooch on the question. There we go. I guess most of you knew what I meant, right? Because most of you got it right. I don't know what just happened there. No, I don't need that. There it goes. Yeah, so most of you got that one right because I don't know whether or not because you knew what I was trying to ask for, but you did. Dang, can't even see it. I'm still not used to this room. But yes, the correct answer to this one here would be A, because hydrosulfuric acid is the only one that's just two elements, right? It would be hydrogen for the hydro part and sulfur for the sulfide part, right? Sulfuric acid is H2SO4, phosphoric acid is H3PO4, and chloric acid is HClO3, right? So the correct answer would be A, right? Which is the following as a binary acid. Not what I said before. I apologize again for that. All right, so let's talk about just real quickly some organic compounds, okay? Organic chemistry is the study of carbon, right? Of like everything you do in organic chemistry is going to be about carbon, right? And the way that we name things in organic chemistry is different from the way we name things in general chemistry. And so if there's a single carbon in the compound, it's called meth, right? So meth means one, right? So here's a methane. Like yesterday, there was a ton of methane coming into my garage. Almost passed out there. You could smell it from like a mile away, right? Probably all those shots of Captain Morgan I was taking yesterday. Maybe that's why I drilled that into the wall. Anyway, then we have ethane. So 2 carbons right here is eth. And most people know ethane or eth from this compound right here, right? And this is ethanol. I'm sure there were plenty of people drinking ethanol last night during the Super Bowl, right? This is also known as ethyl alcohol. Right? So remember here, okay? Remember the eth, right, means 2 carbons. Oh, I'm sorry. You probably don't even know what that means yet. You haven't learned about line angle drawings yet. So there's a carbon right there. There's a carbon right there. There's hydrogens there. And then hydrogens here. There we go. Right, so that's ethanol, right? There's propane, which, I think that what I did was stupid, but what my neighbor did yesterday was even more stupid. He's got a propane tank, right? And not propane tank, a propane grill. And for some reason, he thought that he would light charcoal inside of his propane grill. In addition to having the propane, it blew up his grill. Bad idea. Don't do that, right? So prop means 3, right? And then one that they didn't even put here, which most people know too from lighters, there's bute, right? Bute. And bute means 4 carbons, right? Sorry, I ran out of space. It looks kind of small. And so when you have 4 carbons like that, what is it called? Butane, like a butane lighter, right? So 1 carbon meth, 2 carbons eth, 3 carbons prop, and then 4 carbons eth. I mean butane, right? So, I just drew this a second ago, but I guess we can talk about it again. So now we have, we have our single carbon here, which is meth again, 2 carbons, eth again, 3 carbons, prop again, right? If you have 4 carbons, I'll just draw it the same way they draw it, just so you don't get confused. We ran out of room, so I'm gonna have to put that up there. Okay, so 1 carbon is meth, 2 carbons is eth, 3 carbons is prop. How many is 4 carbons? What is that called? Bute, right? But specifically, what we have here now is an alcohol group, right? This OH group right here is an alcohol group. And so whenever you have an alcohol group at the bottom, connected to a carbon chain like that, you add the suffix ol in there, right? So that's why you have methanol, right? Or ethanol, which is drinking alcohol, propanol, right? So what would the 4 carbon one be called? Butanol, exactly. Butanol. So yes, this the only one you'll have. Just so you know, there's a crap ton of functional groups. But the only one you really need to know is this one, alcohol. That's called a functional group, right? Well, yeah. So that's you could call it, like I was saying before, like ethyl alcohol. You could also call it. That's correct. Absolutely. You could say butyl alcohol. That's another name for it. You could name it that if you wanted to. They mean the same thing. So one is like what they call the common name, which is butanol or ethanol, right? And the other is called the IUPAC name, which is it stands for the International IU Union of Practicing and Applied Chemists. And they name things with the butyl alcohol, right? Or ethyl alcohol, right? But most of us normal chemists, we just call it butanol or ethanol, methanol, right? So that's called the so these up here are called the IUPAC names. But then these right here are called the common names, right? Common names. Okay. But yes, that's correct. That's absolutely correct. But just know that if you ever have a just know that if you ever have an alcohol on it, you're going to end it with an all, right? All right, and the last slide for today, right? Before our oh wait, so sorry, two more slides. Okay, so I already talked about this. Oh, okay. So for things that have more than like two carbons, right? We have to actually say where the functional group is, right? So if you remember, we saw this molecule a second ago, which is propanol, and the alcohol part is connected to the very first carbon, and so we call that one propanol, right? And so one propanol means that the alcohol group here is connected to the first carbon. So what is this down here then? Well, this down here is called two propanol, right? Because the alcohol group is connected to what? The second carbon. Make sense? Right? Really simple that way. So can I do this and put another? What if I move the alcohol and put it here? What is it called then? No, it's still called one propanol, right? Because you can flip it, and it's the same molecule, right? If you rotate this around to this side, right? It's still the same molecule, right? So it's still one propanol, right? I saw someone say it right. Was it you, Chris? Good job. Um, but yeah, the only one that's actually different is the one where the carbon is attached in the middle, right? Good stuff. Good stuff. All right. So this is your last question for today. And I'm going to go ahead and end it on this question. And we'll start talking real deep about compounds and stuff next time we come in, which is on Wednesday. Which of the following organic prefixes represents two carbon atoms in an organic compound? Hopefully that comes up with the right answer, right question. Did it not? Did you at least answer the other ones? You did? Okay. Because it's for attendance, you know? So as long as you answered the other ones. All right. So how many people are in here? A lot. There's a lot, actually. Because I'm bad at counting. 7 on one side, 10, 12. There's 12 people. Okay. Still waiting for a couple more answers. Give your classmates a chance to answer before you leave. I'm letting you out of discussion like 30 minutes early, so be appreciative. Go spend time with your loved ones. It's Valentine's Day. Exactly. My girlfriend wants to throw me out a window for making her not have a hot shower last night. So I don't know what I'm gonna do about that. Anyway, how? There's no gas. I can't cook. That's true, and I have an air fryer. I could just use the air fryer. I'm a little frazzled with this whole thing. I'm Bunsen burner. You need gas for that. You need gas for that. All right. So you need gas for a Bunsen burner. So most of you answered B, which is correct. It is indeed B. The F prefix means two carbons. Have a great week. I'll see you on Wednesday.